Hi, my name is Logan Hagan-McAnany. I'm an undergraduate research assistant for the Harris Lab at the Kansas Biological Survey. My poster is over biochar filtration and how it removes TN and TP from aquatic systems. For a bit of background, Marion Reservoir in central Kansas suffers from harmful algal blooms on an annual basis. These harmful algal blooms are fueled by excess nutrients, namely nitrogen and phosphorus, that enter the lakes from agricultural runoff. Therefore, reducing these nutrients can help us reduce these algal blooms. We tested whether or not biochar can bind to these nutrients, and to do so, we used 12 1-liter sand mixtures filled with Marion water. We took aliquots of biochar, weighed them, placed them on a cloth, and bound them tightly with zip ties, as you can see here. This was done because the socks that the biochar came in are like 2 feet long, and you really can't get smaller sizes, so we had to create our own. We had 4 treatments with 3 replicates each, being a control, 10 milligrams of biochar, 50 milligrams of biochar, and 20 milligrams of biochar. We put these bags into their respective jars and stirred them for 24 hours, and then sampled them for total nitrogen, total phosphorus, and orthophosphorus at 0 hours, 1 hour, and 24 hours. These samples were analyzed at KSU's soil testing lab. Over here, you can see a chart with the total nitrogen, total phosphorus, and ortho-P at 0 hours, 1 hour, and 24 hours, respectively. You'll notice something here is that the 1 hour mark for each of these treatments, for TN and TP at least, shows a higher concentration of TN, TP than the 0 mark did. This is likely due to elements that were present within the biochar itself. See here. So biochar treatment led to an initial increase in TN and TP, likely due to elements present within the biochar itself. By 24 hours, however, TN and TP were significantly lower in all biochar treatments compared to the control. Dissolved ortho-P was also significantly lower than the control in the 15 and 20 gram treatments, but not the 20 gram treatment. So although biochar initially leaches nitrogen and phosphorus, by 24 hours, the treatments with biochar were successful at removing significant amounts of TN and TP from the Marion source water. You can see that over here. We have the controls at 24 hours and then 20 gram biochar treatments at 24 hours. And if you can make it out, the 20 gram treatments are significantly clearer than the controls were. And yeah, so dissolved P fractions were more difficult to remove with biochar, indicating there are relatively more biochars needed to remove dissolved phosphorus compared to particle-bound P. Biochar seems capable of reducing nutrients in aquatic systems. However, retrieving and storing nutrient-laden biochar will require future logistical planning, and future research could examine how modified biochars compare to non-modified biochars. For references and more information, you can scan this QR code. And yeah, that is all.